So in this example, we have an astronaut that's trapped outside of her spaceship. She's 100 meters away, and she has to be able to get back to the spaceship before she runs out of air. So initially, the system has zero momentum. When she throws the wrench, she'll give that wrench some forward momentum, which will then supply her with some backwards momentum. And what this allows for is for basically, if she can throw the wrench fast enough, it will let her return to the ship. And so what we want to determine is how fast does she have to throw the wrench in order to get back to the ship before she runs out of air. One other little side note, the 10 meters per second in the image is misleading. The velocity of the wrench is the value you're trying to calculate. I use this image from your textbook and change the question. So in order for her to get back to the ship without running out of air, she's got 20 minutes to go 100 meters. And so we can determine what her velocity has to be to get to the ship. And so the astronaut needs to travel at 0.0833 meters per second back towards the ship. So to determine how fast she has to throw the wrench, we can use the idea of the conservation of momentum. That momentum initial is going to be equal to the momentum final in this closed system. So just for the sake of the problem, we're going to say that the positive x direction is the direction that she's throwing the wrench. If we solve for the velocity of the wrench, we find that it's 8.33 meters per second. So if she throws the wrench 8.33 meters per second away from the ship, the momentum of that will cause her momentum to send her back in the opposite direction to get to the ship before she runs out of air.